Next.js 13's React Server Components is forcing us to fundamentally rethink how we get data onto our servers and how we render our pages. With Next.js 12, we only had one option. We had to use get server-side props so we'd get the data all at one point, and then we would move it around using props and context. With async React Server Components, you can get the data wherever you want on the page, which is awesome. But with that awesome power comes a potential downside of the N+1 anti-pattern. So I'm going to show you what that N+1 anti-pattern is, how to avoid it, and how to test the performance of your page. Let's get right into it. A lot of you said you were bored with Pokemon examples, so in this one, we're going to use iPhones. So we have a database of iPhones here on this big list, and it's a pretty simple API. Over here on port 8080, we have our iPhone API, and it gives us back a list of all of the IDs of our iPhones. And then we can get information about any specific iPhone by just using / and then its ID, in this case, iPhone 11. I actually had one of these back in the day. I think it's up in some gadget box up in the attic. So this is a classic REST API. You get a list of all the entities on the / route, and then if you do / and then the ID, you get all the information about the specific entity. So let's go build out our next app and see a couple of different alternatives for building out this application. Over here in our project, we have the iPhone API directory. That has the API that I just showed you. It's an Express API. It statically serves the images, plus it has routes for /, which gives you all of the phones, identifiers, and then /ID, which gives you all the information about a phone. So you can see I put in a 50 millisecond timeout on both of these, and that gives us a latency of 50 milliseconds when it comes to this API. A really good API will get back to you in, say, 10 milliseconds. A really slow API, probably 100 milliseconds. So 50 milliseconds kind of splits the difference. We also have a tester directory. We'll get into that in just a bit. Okay, let's go build out our Next.js 13 application. Let's use npx create next app on the latest, which is going to give us 13, and call it N+1. Because that's what we're looking at, the N+1 anti-pattern, and we'll use the experimental app directory to get the app router. We'll use TypeScript, ESLint, Tailwind, and we'll use the source directory. Now I'll go into that directory and run pm-pmi to install all our dependencies, and pm-pm-dev to run the app. And now that's up on port 3000. Let's go take a look. Okay, we've got our basic Next.js landing page. Looks good. Now let's take our / route and build out our first version of this iPhone shower. So I'm going to remove most of this. I'm going to give ourselves a 3-column layout in medium. The first thing I want to do is get all of our data so we can ensure that we have a good connection with our API server. To do that, I need to turn this into an async function so that I can use fetch inside of our home. And now I can use fetch to go get our data. So I'm just going to fetch all of the identifiers, the IDs, and get those back as an array of strings. And let's just go put that in there as a JSON stringify. And now the next thing we need to do is start up our API. So I'm going to go create another terminal window. And now I'll go into that iPhone API, and I'll just run the index file. And now we're listening on port 8080. Rockin'. Okay, let's see how we do. Now we actually do have all the data. It's just in black text. We could actually change the text here to be white. And now we can see that we have all of our IDs. Good start so far. Now that we know that we have a good connection to our server, let's go start building out our grid. To do that, I'm going to create a new component called phones. It's going to take a list of identifiers that we just got, and it's going to go and map through all those. Now down here, I'll just instantiate that. Looks pretty good. Looks like a 3-column layout. That's good. Let's go now build out the cards so that it looks good. So I'm going to build out the phone card. It's going to be an async component because it's going to go off and get the data that it needs to show that card. It takes an identifier and it then runs the fetch to go get the specific data for that phone. But for the time being, I'm just going to return this div, and then I'm going to instantiate this phone card. And we can see that we're getting this red squiggly. So what does that red squiggly mean? Well, that means that we can't use this JSX component because it's an async component, except that we can because we're Next.js 13 and it's a React server component. So actually, we're just going to ignore this. And to ignore that, we're going to just use the TS expect error and say that, hey, if it's giving us an error about being an async server component, yeah, we get it. It's not a problem. So now let's go get that data. And we're going to go get the localhost 8080 with the identifier, and we're going to coerce that into an iPhone, except that we don't have an iPhone TypeScript type, so let's go build that. To do that, I'm going to create a new types file right up here at the top of source and put in there a type for our iPhone, and then we can just import this into our page. Okay, now I'm going to bring in the formatting for our card. It's going to have a card component, and then we're going to lay out the rest of the data, the image, which is going to be relative to 8080, and then all the information about the models. Let's go take a look. Okay, issue number 1. Now it's telling us that next image isn't happy with the image location that we're giving it. We're telling it that we have an image off of localhost 8080, but it's not configured to show that. So let's go configure it. To do that, we go over into our next config.js, and then under experimental here, we add a new key called images, and we say that we have a remote pattern of localhost on 8080, and anything under there is fine for images. So we also need to reboot our server. And now it looks good. It's not quite right, and that's because I used Daisy UI to put together the card for this. So I'm going to quick install Daisy UI. I'll go back over to our terminal. I'll add Daisy UI as a development dependency. And then over in our Tailwind config, I'll add it as a plugin. And that's it. That's as easy as it is to install Daisy UI. Let's run our server again. And now we have a nice looking display. Awesome. So now we're all set up. Everything's looking great. But underneath the hood, we're actually making a whole bunch of requests to the backend server. Let's take a look. So we're making one request at the top here to go get our list of IDs. And then we are instantiating in phones a whole bunch of these phone cards, which are in turn making one request each to the API. That's where N+1 comes from. This is N, so we're making N requests, one for each card, and then the +1 is the original request that we made. So if there are 50 iPhones that are making 51 requests, we're getting the 1 to get the list of iPhones, the 50, and then we're making the 50 individual requests to get the data for each iPhone. Now, to understand the performance impact of this, we kind of need to actually have a baseline point so that we can see if different approaches make our page faster. So we need to know how fast our page is. To do that, I'm going to use a tool called oh-my-posh. Now to do this, I'm going to actually make the font size a little bit smaller, so it may be hard to actually see the command that I run, but it's worth it since the output of oh-my-posh is really cool. So I'm going to do oh-my-posh, and then I'm going to give it a duration of the test as 10 seconds, so Z 10 seconds, and then I'm going to give it the URL that we want to hit with our test. And that would just be the / route on localhost. So let's hit return. And now, yeah, you can see why I made the font size smaller, so we see all these cool graphs in real time. All right, so what has it told us? Well, it told us that on average, we are getting a 0.9 second response from the server. So every page comes in at about 900 milliseconds, which is okay. Now, since we're doing a couple of different variations on this, I want to keep track of the different performance numbers. So let's go and copy this. And then create a new file called performance.md where we'll keep a record of the different performance numbers that we get. So we'll call this the / route, and we'll say that we get a speed of 0.9098. Okay, not bad. In fact, we can preview that and see that we're going to get a nice little table out of that using all that markdown formatting. Now that we have our baseline speed, it's important to understand that Next.js is actually doing a lot of caching for us. Every time we do a fetch here, we're actually not doing a fetch to our API server except for the first time. Next.js is aggressively caching our requests. Once we do it once, we never do it again. So let's turn off the caching and see how much slower it is. To do that, we add options for cache, and we just say that we don't want cache. Let's do that for both the initial request, the 1, and then the N. So we're going to turn off caching in both places and see how we go. Let's rerun the oh-my-posh. Now we can see that it takes 1.4 seconds to build the page because we're no longer caching. Let's go and store that data. And you know what? I think we should restore the caching and then talk about how you could potentially invalidate that cache. So I'm going to take away the no cache, which restores the cache. And now if you want to use this caching, what you can do is you can export a constant out of here called revalidate. And what revalidate does is it says every, say, 60 seconds in this case, and you can specify that number for yourself, it should go and invalidate the caches. And so now this route is going to invalidate any caching it has every 60 seconds or on the next page fetch if it's been longer than 60 seconds. Now let's see if we can do better. And to do that, I want to be able to take each iteration that we have and store it in a different route. So I'm going to call this route N+1. So we'll create a new directory called N+1 and put it into their page.tsx and copy that page. And then back up in here, we'll just get rid of all this contents. So now our original test is on N+1. Let's go take a look. Awesome. And over in our markdown, let's change the slash to N+1. Now you might be saying to yourself, hey, they've come out with this new cache function in React. Does that help? Well, let's try that out. Let's go take page.tsx and create a new directory called N+1 cached and create a page.tsx in there and paste in our code. And let's just make sure it works. We'll go over to cached. Looks like it works well. Now let's go bring in cache. And now we need to create cached versions of the phone by ID getter and the phone list getter. So let's do the phone list version first. So now we've created an async function that does exactly what we did before and returns the list of phones, and then we've wrapped it in a cache. So let's go use that. And there we go. Let's do the same thing for our get phone by ID. Now we have get phone by ID. It takes an identifier. It's also async, does exactly the same thing. And let's try that one out. Okay, let's see if it works. Seems to work. Now let's oh-ha it. So I'm going to use that same oh-ha command, but this time I'm going to fire it at N+1 cached. Oh, wow. This is actually significantly worse. Huh. Okay, this is actually far worse than I've seen in other tests. It's always worse, but this is actually worse than usual. Comes in around 1.89 seconds. Jeez. So let's compare that to what we had before. So we had 1.42 in the uncached version, and now we've got 1.89. Jeez. Now, why are we seeing this result? Well, fetch is already cached, and what we're doing is wrapping it in another cache. Now, I've seen it be bad, not this bad. This is extraordinarily bad, but it's not good. So long story short, don't wrap fetch in another cache. It's already cached. But clearly, I think we've pushed the spot solutions here about as far as they're going to go. And my recommendation at this point would be for us to create a backend for Frontend, which would give us an API that is more performant. So what do I mean by that? Well, we have an ability in Next.js to create an API route inside of our application. In this case, we have the hello route that gives us hello Next.js. Now, obviously, an API endpoint that tells us hello Next.js is pretty worthless, but what if we had an API where it gave us all of the information about all the iPhones in one shot? Well, we can't ask our API folks to do that for us, but we can create our own route that does that. Let's call it iPhones. So create a new directory called iPhones. And then in there, a route.ts. So this is a route handler as opposed to a page handler, which would be page.tsx. And we'll import next response. That's going to give us an ability to quickly return JSON, and we'll give the iPhones API, which we'll say is going to be on an 8080. Now on startup, I'm going to go get all the data. I'm going to make that fetch that iPhone's API. That's going to give us back our list of identifiers. And with those identifiers, we can go off and make all the subsequent requests and build up our data that we want to send back as our big payload. So we start off with a data array. We go through each one of our identifiers. We do that fetch. We go and get the identifier. And then we just push onto that array the data that we got back. And then at the end, we return data. So now the output of the complete data promise should be all the data. And it's going to go get it once when the application starts up, or the first time that that route is fetched. Now to return it, all I need to do is create the get verb and return an await of the complete data. And you might be saying to yourself, wait, hold on. If you do an await here of the complete data, then isn't it just going to go and request it every time? No. Once the promise is resolved, it's just going to return the resolved data over and over and over again almost instantaneously. So let's go and try this out. So I just go to the iPhone's route. And we can see all the data for all the phones. This is going to make it a lot easier to create a much more performant page because instead of N+1, we're just doing 1. So let's try that out. Let's see if we can make an aggregated page that uses this data source instead of the original 8080 data source and see how much more performant it is. So let's take all of our N+1 and then create a new directory under app called aggregated and put a page.tsx in there. Paste in our implementation. And now, instead of talking to 8080, we want to talk to 3000 iPhones. And we're not going to get back identifiers. We're going to get back full iPhones. Now we don't get identifiers here, we get iPhones of type iPhone. We're going to go iterate through all those iPhones, and now we have an iPhone there. Now the ID should be something like identifier. But we want to pass on the iPhone as is, as a complete coherent object. And honestly, we don't even need an async server component here because this phone card is just going to go and display the data that we have. So let's remove that and go back over here to phone card, remove the async, no longer need that. And instead of identifier, we have iPhone. And let's get rid of all this. And now we can just change phone to iPhone. Okay, let's try this out. Wow, and there it is. It looks good. Let's give it a try under oh-my-posh and see how it performs. Oh yeah, that came in way faster. This time it's coming in at 0.66 seconds. Let's go see how that compares. So 660 milliseconds versus 909 milliseconds. That's a 240 millisecond savings. That is excellent. Now, if you found this helpful so far, can I ask you a favor? We're running a survey right now on Blue Collar Coder to figure out what interests you. And if you can just take the time to fill that in, there's a link in the description right down below. That'd be super helpful. It not only helps me figure out what content you like, it also helps me figure out who you are. And that's going to help me connect to marketers who want to market on this channel. And the idea here is simple. I'm going to be using advertising dollars from vendors that we all know and respect and use that to fund doing the basic research and bringing all of this to you for free. Okay, let's get back into it and start talking a little bit about how this compares on the client. So I want to bring in this other tool that I created. And this tool is called Tester. So let's pack this up a little bit. And I'll create a new terminal. And then I'll go into that tester directory. And now I'm going to run tester. And I'm going to run it on our original N+1 route. And what this tester does is it looks at the returned payload in more depth. And what it tells us is that we have 61K of HTML, and that's what is actually displayed on the page. And then we have another 75K of JSON. That's the persisted VDOM that initializes the client. And that JSON is actually pretty interesting. It's a combination of the DOM elements. So for React server components, that would have all the class names, any keys that are intended for HTML. And then in the case of client components, it has any props that are sent to those client components. Now, since we don't have any client components in this case, we have 0 kilobytes going to the client. Now let's try the same thing with aggregated. And what we should see is almost exactly the same numbers. And we do. We get 60 KB, 73 KB. And again, no client data because we have no components that are registered as use client. So I want to take a look and see if we decide to go and make these cards interactive at all, are we going to pay any kind of performance penalties for that? And this has actually changed since the first time that I looked at 13.1. The structure and content of this JSON has become a lot more optimized. So that's actually really good. Now I want to see if we take these cards and we turn them into client components, how does that affect what actually gets output from the server? So to do that, I'm going to start with aggregated. I'm going to create another folder called aggregated client, and I'll create our page.tsx and paste in our code. And now where do we want to cut the client? And my thinking is that we should cut the client at phones. So phones here is going to be a client-side component. So let's go and copy everything into a new components directory. And we'll call this phone client. And we'll paste that in. Now we don't need the home. Don't need this. And we're going to export phones. And importantly, we're going to make this a client component. So we need to put the client directive in there. And now over in our aggregated client, we can bring in phones from that file. Now we brought in phones from our phones client, which is now a client component. Let's go see how this works in the browser. Okay, looks good. Let's hit it with oh-ha and see how it performs. Okay, it looks like it's doing a touch slower at 0.87. Go put that into our performance. So a touch slower than N+1, but still not as bad. Interesting. Now let's look at that tester and see how the structure of the JSON has changed based on this move to a client. All right, so let's put our aggregated client at the top here and then our aggregated down below, and so we can do a comparison. The HTML remains the same at about 60.6. Makes sense. With the client version, there's now a little bit more JSON, but interestingly, about 77% of that is all of the data on the phones that is going to the client. Now, how do I know that's there? Because if I go over to our arc and then I do view page source, and then I do line wrap, I can see all of the HTML at the top, okay. And then I can see all of that iPhone's aggregate data going to that phone's component, which is then distributing it to each one of the interior phone cards. And so that's where that 75K of data comes from. That all has to go down to the client so that now those phone cards can be rendered on the client and be interactive there. As opposed to with the original aggregated, where we didn't have anything on the client, so we had 73K of data, which was just all of the information about the HTML. Now, in older versions of the app router in Next.js 13, this wasn't as optimized as it is. You generally speaking have the 73K for the HTML plus the 75K for all of the client data. And in fact, you might actually have multiple copies of the client data depending on how you distributed it with properties. So I'm glad to say that Next.js's app router is really improving as we see the betas come around. Now, one more thing is I want to show you how to not do data distribution on the client. So we're going to create another version of aggregated client called aggregated client bad, because this is going to be bad. So again, we'll start off with aggregated. Create a new other folder called aggregated client bad. And into there, page.tsx. So this time around, I'm only going to make the phone card the client component. So let's copy that. We'll call it phone card bad. And what it's going to do is pretty nuts. It's going to take the list of iPhones as well as an identifier, which will be a string. And then it's going to find in that list of iPhones its current phone based on that identifier. And then it's going to render that out. And you know what? I'll put a bang here to say that we're always going to find it. And now let's go into our bad and let's remove the phone card and import it from the bad phone card. And now it's telling us, well, you're not sending the right data, so we need to send it iPhones as well as the identifier. And I got to get rid of image. And I forgot to make this a client component, so let's go and make that a client component. And let's see how bad this is. So I'm going to go over here to Arc. I'm going to hit refresh. And it doesn't seem too bad. Let's give it a try. So I'm going to go over to our oh-ha and hit it. And oh, this is not good. Okay. So yeah, this is not good. We're getting a 6-second return time. Well, let's go over and log that. So whatever this is doing, we don't want to do it. So let's go over here into our tester and see what exactly is coming out of there that is bad. So if we do aggregated client bad, and we compare it to our regular client, we can see that we're getting 60K of HTML as we did before. We can see that we're getting 6 megabytes of JSON, of which 4.85 megabytes is the client data. So what's happening here is we've sent iPhones, the entire array of iPhones, to each individual phone card. And because each one of those is individually its own use client, that means that it has persisted the props to that client component, which means that we have as many phones as we have times the total payload coming in from the aggregated API. So that's really where you have to watch out. When you make that transition from a React server component, in this case, phones, to a client component, in this case, phone card, everything that's going to that client component is going to be persisted in this JS data that goes to the client, which can get very big if you're not careful and seriously impact the performance of your server. All right, well, I'm posting all of the code here and all of the results up to GitHub. You can go check those out for yourself and try for yourself to see if you can reproduce all of this and get these insights for yourself as to what kind of request structures you want to use with your React server components. And then as we transition into client components, how you want to go and send data to those client components. Now I want to know from you, your thoughts and your experiences when it comes to Next.js 13 and React server components and how that all works together in the comments right down below. In the meantime, if you enjoyed the video, hit that like button. And if you really like the video, hit the subscribe button and click on the bell, and you'll be notified the next time a new blue collar coder comes out.